Okay, so today let us look at how to find antilogarithms. And so meaning that last time we had looked at finding logarithms, but today let's look at antilogarithms. So let's write by saying finding antilogarithms of numbers using mathematical tables. Okay, using mathematical tables like that. So on your screen there you can see the table there, and that table contains the antilogarithms of numbers, and these numbers they range from 0.00, like here you can see in the first column. It is ranging from 0.00 up to 0.99 in your tables, which you will see there. But for me, I have just a small fraction of the table, and we are going to just be using part of it like that. So also it has columns like there, the first column, second column, like that. Zeros column, they are numbered from 0 up to 9. Okay, those columns there. And then also we have the other part of the table, which is for mini difference, or we call them, okay, something they call them addition parts. Okay, or you find I've written there just that add. So when we come to this, you are going to see how to get there, how to get the antilogarithms using this table. So let us just say like this, that the logarithm of 2.4 is 0.3802. When we use the other logarithm tables to get the log of 2.4, you find that the answer which we get is 0.3802. So, but now when we come to this, we can say that the number whose log is 0.3802 is called the antilogarithm. Antilogarithm is known as or is called the antilogarithm of 0.3802. okay, which is 2.4, which is 2.4. So you find that in last time we looked at how to get logarithms of numbers, but now today we are looking at how to get the antilogarithm of still some numbers. So here we are now moving from a value of a log back to that value. Okay, like we have here log of 2.4 is 0.3802. But now when we say the number whose log is 0.3802, when we are talking like that, the number whose log is this, we are the same as saying antilogarithm. We are saying like we want to get the antilogarithm of this 0.3802. And when we find antilogarithm of 0.3802, the answer which we have to get, it has to be 2.4. So we are moving back. So antilogarithms, it is the reverse of what? Of logarithm, like that. So when we proceed there, we can say again on a new line that antilogarithm of that 0.3802 when we get antilogarithm of 0.3802, we get 2.4. That's what we have to know. Okay, then but also we need to know that we can write it like this, that simply written as the antilog, that is of 0. So I'm not writing there of, but I'm just writing antilog, that is 0.3802. So when we write like that, its answer, it has to be 2.4. But some people can write like that. We can write like that as antilog of 0.3802, and the answer is this. Or we can write it like this. I can write 10 and then I raise it to power 0.38, that's 02. So when I write like this, then still it means that I'm looking for antilog of 0.3802, and the answer has to be 2.4. So antilogs, this is how we write them. We raise them, it is 10 to the value 10 raised to power of that log. So antilogarithms, we write them like this. Okay, that's 10 to power 0.3802. So it is from the table where we look for the value of this. We look for the value of this from the table, and when we look for this value, we find out that the answer which we have to get, it is 2.4. So I think let me show you now how to check that answer from the table. So from the antilogarithm tables, okay, let us see how to read that. Remember, we want to get antilog of 0.3802. We want to get the antilog of this. So let me show you how to get it. I think when we come to our table here, when we come to our table here, we have to look for 0.8. I mean 0.38. We first look for this 0.38 point. So you can see the first column, it has point, then there are 2 digits there. So we look for 0.38. You can see that 38 is somewhere here. Okay, 38 is around here. So after 0.38, we are followed by 0. So meaning our answer has to be on the zeros column. So on the 0 column, on the zeros column, this is the column, okay, or along the zeros column. So meaning that the answer has to be here, and that answer is okay, the digits which are there on the zeros column at 0.38, the values are, we have 2, we have 3, and then we have 99. There are 4 digits. We have 2, 3, 9, 9. Okay, so when you write them down, you put a decimal point between the first 2 digits. Like in this case, the first 2 digits are 2 and 3. So you put a decimal point in between these 2 digits. Okay, that's between 2 and 3, so that the answer becomes 2.399. Then after that, there is this 2. Now that last 2, we have to go to that part of adding. Okay, So that part of adding along this column, I mean along this row of 0.38. So you find that we come to that part of adding. This one lies on the first column, but now on the second column it is also 1. So meaning that we pick that one and then we add it on the last digit here, which is 9. So we add it there, and when we add 9 plus 1 we get 10. We write 0 and then we carry 1. Then 1 plus 9 again we get 0, I mean 10, we carry 1. We write 0, we carry 1, and then 1 plus 3 we get 4, like that. Then here it will be point, and then here that's 2. So there you can see clearly that it means that the antilog, or that's the antilog of 0.3802, the antilog is simply equal to 2.4. So you have seen this, we have got it from the tables, like that. So that's the answer.